So the guys from Inventables contacted me recently and they asked me whether I was interested in having a look at their new machine they were about to release, their new desktop milling machine called the X-Carve. So of course I said yes, and today I've had a number of boxes show up. They've travelled halfway around the world and they've got here in one piece, which is good. And I've got the box with the electronics here, I assume, and I've also, behind me, and I'll show you in a moment, I've got a big wasteboard and I've also got some long aluminium rails. So let's get stuck into it. We'll open this box up and we'll have a look at what we've got in here. So all the components were packed and labelled really clearly. I was amazed at how they managed to fit so much stuff into one box actually. So the first thing I tackled was the wasteboard. I've got the larger of the two machine sizes available, so this wasteboard is 1 metre by 1 metre. Now it comes pre-drilled and the holes are countersunk on the back, which saves me a lot of time. So I sort out the threaded inserts and I use my drill to run them in through the back of the wasteboard. I'm starting work on the X-carriage assembly first. The hardware is all bagged and Inventables have done a great job of labelling all the bags clearly. The website has detailed assembly instructions and videos, so between a combination of both of those, it makes putting the machine together pretty straightforward. So here I'm attaching a spacer and then the smooth idler wheel and tightening it all up. There's a couple of those go in and then we can insert the V-wheels. Again, being careful that we assemble each of the components in the correct order. Pretty soon we've got all of the wheels attached and we can screw the NEMA 23 stepper motor onto the back. A drag chain angle bracket gets attached and we also attach a terminal block. We'll use that later to wire the stepper motors up. So with the X-carriage assembly complete, we can start work on the Y plates. I'm scrolling through the assembly instructions and checking what hardware I need for this particular step and then just sorting it out ready to use. Again, we're attaching smooth idler wheels and V-wheels to this assembly. There are a few holes on this plate, so you need to make sure that you're using the correct ones. And when you're finished, you should have two plates that are a mirror image of one another. Each of the Y plates has a NEMA 23 motor attached to the back. Now here I'm assembling the gantry and it involves using self-tapping screws to tap the ends of the maker slide. Now a lot of people on the Inventables forum found this step to be cumbersome, but I found it pretty easy to be honest. I held the maker slide lightly in my bench vise and that freed up both hands so I could hold on to the assembly and tap it. With one of the Y plates screwed on, I could now slide in the X carriage that I assembled earlier and then finally attach the other Y plate. And then I just slid it forwards and backwards for half an hour, admiring my handiwork. The next step was to assemble the X-axis, and I used the same technique as before, holding the maker slide in a vise while I tap the ends with the screws. So it's starting to take shape now. I can slide the gantry onto the Y-axis and then attach and tap the ends. And here I'm just dabbing on some WD-40. It was in a tip in one of the Inventables videos, so I gave it a shot and I think it helped. And this is the Gt2 Belting and it's used to move the machine around. It just slides in over the top of the pulley wheel and under the smooth idler wheels. One end is fed into a bracket and then over on itself. I'm using some heat shrink tubing to make sure the teeth mesh in and catch properly so the belt doesn't slip. A button head cap screw allows me to position it right at the end of the maker slide and lock it in place. And it's the same process on the other end as well, except the addition of an adjustment screw and nut, which allows us to tension up the belt later. And then we just repeat the process on both Y-axes. This is the last of the tapping that needs to be done. Here I'm attaching the Z-axis motor plate to the maker slide. A NUMA 23 motor and belt are attached and then tensioned up. This is the spindle carriage. Again, just more V-wheels and idler wheels. Once that's assembled, it can be slid into place and the spindle can be fitted in and tightened down. So at this point it's looking pretty complete. The wasteboard is in place and I've got the drag chains attached and the wiring is routed from all the stepper motors to the front left corner of the machine. I've tidied up the wiring as much as I can with various sizes of sleeving, and I've used crimp connectors on all the stepper motor wires. So the final step is to assemble the electronics. Here's the 400 watt power supply and the faceplate. There's a small interface PCB that attaches to the power supply. We just need to back out some of the screws, slot the PCB in place and screw it down. The faceplate slides over the front and tidies everything up. It's secured with a couple of screws on the side. There are two PCBs that are mounted into the enclosure. This is the Arduino board and there's also a G-Shield board as well. The Arduino gets screwed down into place first and then the G-Shield is pushed down on top. The assembly is finished off with a fan enclosure that screws onto the top of everything. And at this point it's time to fire everything up and make sure it's working. And that blue light is exactly what we want to see. So the next step is to head over to the Inventables website and launch the easel app. We need to sign into the website. Easel opens and now I can set up the X-Carve and make sure it's communicating with the PC. Now I can confirm the size of the machine I've got, which is 1000 by 1000, and the lead screw type I have is Acme. And then I need to select the COM port that the Arduino is connected to, which in my case is COM port 3. And now I can test to make sure that my stepper motors are wired correctly and that everything is moving in the correct direction. I can use these buttons to jog the machine along all three axes. So everything's looking good, so I can click yes to everything. Now you can choose to have the spindle controlled automatically by easel, so we'll select automatic and we can test that. Now that's looking good. Right, now we can actually design something and make our first cut. So this is the interface for easel. And you've got all of your basic geometric shapes up here. Just shift that into the middle. We can enlarge that a little bit. This pop-out menu is our toolpath generator. So we can actually cut on path. You can cut outside if you just want to cut the square out. You can cut inside, of course, and you can also fill, which will remove all of the material. Our depth of cut is controlled by this slider, so if I slide that all the way down, you can see over here in the 3D preview that we've got a representation of what we've just done. We can cut all the way through the wood there, so that works pretty well. You've actually got a bunch of fonts that you can import, and you can do exactly the same thing with those. Now, the beauty of this program is it imports vector files, SVG files that you generate in Inkscape or Adobe Illustrator. So you can import a SVG quite easily. Just grab this one here, bring that in, just shift it over. Now, if we wanted to cut that out and make some templates, we would cut on the outside like so. Make sure the depth of cut is all the way through, and you can see we're cutting all the way through over here. Now, the beauty of sliding this all the way through, so you're cutting completely through the wood, is it adds in tabs. You can untick that, of course, but you're better off having the tabs there so the parts don't come flying loose when you finish the cut. Now, if you do your artwork in Inkscape, you've actually got a free software path from drawing your part right through to carving it on the CNC. Inkscape is free, Easel's free, so it's a pretty good deal. We'll just get rid of that, and I've got some artwork that I've done up in Adobe Illustrator. It's a little sign that we're going to carve. Just grab that and move that over a little bit. You can adjust each of these letters individually. We might just skew that on its side a little bit, and we'll do the same with this C. For no reason at all, we'll just enlarge that A. So that looks pretty good. In fact, we're cutting all the way through the wood at the moment, which is not what I'm after. I just want to engrave that down 1/8 of an inch. So we can use the slider here, or if we want to be exact, we can just go 0.125 and we're done. I've got it set to fill, so it's actually going to carve all of the material away inside of those letters, and it's going to carve down 1/8 of an inch. So once I'm happy with that, I just hit the carve button and that will generate all the toolpaths. In fact, I'll show you the toolpaths. If I click on generate toolpath, you can see over here the red is the router traveling to the various locations, and the blue is the actual cutting path of the bit. So that's pretty cool. You can hide the material if you choose to and just see the path, and just make sure that everything looks right before you send it. And that looks pretty good, so I think we're in good shape. We're ready to send this to the CNC and create our first piece of work. Now, those 144 threaded inserts I screwed into the back of the wasteboard now come in handy. Now, I'm asked to select the thickness of the material I'm cutting, which in this case isn't important because I'm only engraving 1/8 of an inch into the top of it. I can confirm that. And it asks me to make sure I've got the material clamped down, which I have. And now I select the end mill, which in my case is going to be 1/8 of an inch. And now I just need to confirm the home position, which is where the machine will start carving from. Now I can use this step interval here. I change it to 1 inch, and I can jog the machine closer to where I want. Now every time I hit the button, the machine advances 1 inch. And when I get closer, I just reduce the step interval down, and then I can jog closer to the top of the MDF. I change it over to millimetres, and now I'm only jogging down 1/10 of a millimetre at a time. I want to zero that bit out on top of the MDF, so I'm using a piece of paper as a gauge, and once the bit is so low that it traps the paper, I can confirm the home position. The software automatically raises the bit and the spindle starts for me, and away we go. So the end result was pretty impressive. A little bit of fuzz on the top of the MDF, but that was caused by the upcut spiral end mill that I was using, so that was easily cleaned up with a little bit of sandpaper. So cutting the sign was fun, but I wanted to get a little bit more serious and actually cut a guitar template. So what you're seeing now is just a CAD file of a Telecaster body and a tool path I generated. I'm just checking the simulation to make sure there's no obvious problems before I cut it for real. So I'm new to all of this stuff, so the feeds and speeds are all a work in progress, as are the tool paths I generated. So I was pretty happy with the simulation, it looked good to me, so we can try cutting it for real now. Now one of the first things I need to get sorted out is a dust shoe of some sort. Right now I'm following the spindle around with a vacuum, which was fun for the first 5 minutes, but it grew pretty tedious pretty quickly. So being able to just draw up the templates, step into the workshop and cut them is going to be pretty cool. I'm taking it pretty easy on the spindle and just using a 1mm depth of cut per pass. I need to get a feel for how much I can cut per pass and not bog the spindle down. I see there's more powerful spindles available, so that's probably going to be my first upgrade, I think. This one's fine for cutting MDF and soft woods, but I wouldn't want to be cutting through 1.5 inches of rock maple with it. So my tabs are a work in progress. I need to make them a little higher. The bridge route stayed put, but the other two popped out when I was cutting them. The edges look nice and smooth. So this is what is left from the tabs that I left in there, and they're easily removed with a couple of strokes from a file. The tabs are only 1mm thick. And here's the end result, a beautifully cut template. Now as a test, I've only cut it onto 1/4 inch MDF, which is really too thin for a template. I need to cut them next time on 1/2 inch or 3/4 inch MDF.